So we will discuss lesson 5, 7, and 6 and 7, and then we'll discuss chapter 4. Yes. Can you hear the music? Can you hear the voice?
Yes.
Okay.
Hi class, welcome to Math is Fundamental. Today we're going to be talking about isosceles and equilateral triangles. So first vocab term is an isosceles triangle, which states that an isosceles triangle is a triangle that has two congruent sides, which we call legs. So we've got one triangle with two sides that have to be congruent. We call those the legs. So this is going to be a leg, this is going to be a leg. Now, a little bit more vocab here, I'm going to kind of embed it into this definition, is that this side, the non-congruent side, is what we call the base. And we have to be careful because the base is not always on the bottom of the triangle. It simply means the side that's not congruent to the other two. All right, so we have that. We also have...
Yes, so you can see yeah, we have 1, 2, 3 topic. Yes, so we have isosceles triangle. That means the two sides equivalent, right? And then we have the isosceles triangle theorem. So if the two sides of triangle are congruent, then and the angle opposite to those sides are congruent. So if this is congruent, and the angle of this facing opposite is angle is congruent. So this one and this one is congruent. So this is the same. And the converse of the isosceles triangle theorem, if two angles of triangle are congruent, then the like opposite angle are congruent. So if this congruent, so this is the side of this side and this side is congruent. And for the equilateral angle, equiangular triangle. So if all of the sides are equal. Okay, so there are two equilateral, all sides are congruent. Angular square angle congruent. So for this one is the side this is congruent, but for this one is like the angle like congruent. Right? And this is we call it the polarities. Polarities are no name, but the equilateral triangles. So if the triangle is called equilateral triangle, then it is also angular triangle. So if this and also all of the sides are congruent. I mean all the angles are congruent. If it's all of the sides is congruent, and also all of the side of and the opposite was the same. Right? So if the triangle are equiangular, then it is also equilateral. Right? So all of this angle are congruent, so there's the side also congruent. Yeah, I think that's for chapter 3, lesson 5, right? And if this is also just example, if you have a isosceles triangle and you need to find what is the x. So that means this one equal to this one, and then you can find the x, right? I mean, this angle equal to this angle, or 2x plus 5 equal to 35, and then you can find, yeah, 2x plus 5 equal to 35, and then you can find for the x, right? And for this one, so the set is the same. Right? If this is 100 degree, so this one will be what? Because this one and this one is the same, right? If this is 100 degree, no, the total sum of all of the angle of a triangle is 180 degree, right? So that means if you subtract 180 degree with 100, you got 800. Sorry, you got 180 degree, subtract with 100, you got 80 degree, right? So because this is the same, so this one will be 40, this one is 40, right? So that means in order to find the x, so you can make it this one equal to 40, right? And for this one, because all the sides are the same, so the angle will be the same, right? I think each of the angle will be 60 degree. Okay. Okay, so she do the other way. Yeah. So she she did it like this. So add this two angle and then add this angle equal to 180 degree, and you can find that. Okay, so the same thing for this one. So you add all of this 3 and it's equal to 180 degree. So you can see this is 150 divided by 3 you got 50. Yeah. Okay, so this lesson 5. Let's go to lesson 6. Congruent right triangle. I think this is clear.
Grammarly can help you write quickly and confidently, so you never have to slow down at work. Stay on top of emails, documents.
Yeah, maybe I should make it bigger here. Yeah, I just keep it. Okay,
Is
so
congruent to another, then the two triangles are congruent. So on a diagram, the hypotenuse leg theorem is a congruence theorem that states if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and corresponding leg or leg of another right triangle, then the two triangles are congruent. So on a diagram, what that looks like is if we have the hypotenuse of one is congruent to the hypotenuse of the other, and we have a leg is congruent to another leg of the other triangle, then those two triangles are going to be congruent. All right, so let's look at a little bit of a note. this postulate is used to prove that triangles are congruent.
Yeah, hypotenuse like theorem, right? So if the lack of
And we now have 5 theorems.
if the hypotenuse and lack of right triangle are congruent to the hypotenuse and lack of the another right triangle, so then the triangle are congruent. Okay, so this is a theorem. Okay, theorem with a proof. Okay, so this particular is used to when trying to prove triangle are congruent. Okay. Yeah, so so now you have what? How many theorem you have? 5, right? 5 theorem, right? Side, angle, right? And then angle, side, angle, side. And then what else? CT, and then this one. Okay. Yes, you can see so you have this theorem, and this is
And one definition to use to prove that 2 triangles are congruent. So review here from our previous lesson videos. We have side, 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 angle, side, angle, side, angle, 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 side, and now the hypotenuse leg theorem. So we have 5 of these, and that's it. We're not learning any more for congruent triangles, just these 5. And then, of course, the definition of congruent triangles, which is a little bit more work for us. All right, so let's look at this example here. We are given a bunch of information.
Yeah, so this is just only example to use to prove the congruent triangle, right? But for you to answer for this lesson, so you only need to answer this one here. So for this lesson, you need to only just explain about this one. So you don't need to discuss about this one.
So on a diagram, what that looks
It's only like a 35 minutes. I mean 35 seconds.
is if we have their leg. Have a note, this postulate is used to
Yeah. So for this lesson, you only have this one. So this one that you need to put in your answer. For lesson 6, right? Okay, let me see. Yeah, so this one only example how to use the theorem. Right? Yeah, I think this one try to use the hypotenuse leg theorem. Okay. So the hypotenuse is congruent, and the leg, one of the leg is congruent. That is close to the hypotenuse, right? And you can, yeah, I think this is known here. Right? Okay. So BE bisect by AD. So PE bisect by
segment
AD.
DE
So,
is perpendicular to E.
so that means this equal to this, right? And then AB perpendicular to, yes, all of this is known, right?
C, and we know that
Okay, just skip this
but a
one.
theorem
Okay?
is angle side angle. So we don't want to use HL, but we have a lot of this is the HL theorem. When we're trying to and move this. All right, and our reasons are true. Other ones, as we know,
Yeah, just skip it.
right, angles are congruent. So just explaining a little bit. I don't remember the exact name of the theorem, but it's okay. In a proof, if you don't remember the exact name, sometimes you can just explain on my diagram. I have this angle is now congruent to this angle.
Yeah.
Ooh, I also have vertical angles. Always look for vertical angles. Let's stop here for just a second. Look, don't have the angle in between. We actually have enough information to stop at this angle. ABC is congruent to triangle DEC by angle side congruence. So sometimes, all right, so that's the proof that proves that H. I think that concludes our lesson for today.
Yeah, so so instead of using the hypotenuse like theorem, he used angle side. Okay. So angle side. Okay. But also automatically, she also proved that if this the hypotenuse are equivalent, and one of the and then the leg also equivalent. So using the hypotenuse like theorem, we can conclude that is those two triangles are congruent. Okay. So any question?
So thank you so much for watching, and remember, math.
Okay, so this lesson number 6 is only explain about hypotenuse like theorem, right? Okay. And for lesson 7,
Are you struggling in your calculus class? Do you have a hard time understanding your instructor? Do you wish there was a simpler way?
congruent and overlapping triangle. Okay.
Hi class, welcome to Math is Fundamental. Today we're going to talk about congruence in overlapping triangles. So let's just read. We have a few bullet points here. Sometimes we're given two triangles that overlap with each other. When triangles overlap, it usually means that they share a side or an angle. So that's going to be important later. In order to more easily match up which sides and angles are corresponding, or to help us in our proof or when solving for variable, we need to separate the two triangles. Super important, separate the two triangles. We'll need to do this really carefully and be sure we relabel the triangles once they're separate. All right, so let's look here. Separate the two triangles and identify their common parts. So we have a whole bunch of triangles here. And let's do, for this triangle, let's do triangle ABC and triangle in green. So we can,
Yeah, I think you can.
and
Yeah,
triangle C. So we can't really.
Sorry, I just skip it. Okay, so you can clear from the picture. Okay, so you need to spread this. You want to prove ABC congruent with AAC. Right? So ABC congruent with AAC. So you need to spread those two triangles. And the same thing for this one. You want to show or prove that triangle ABE congruent with triangle CBD. So you need to spread this triangle also. Okay? And then you can prove that this this two triangle are congruent. Okay? Yeah, so this is the step that this. So she just want to show this one. Right. Want to prove that ABC or BAC congruent with ABE, right? So ABE, this one with this one, right? Okay. And you can see here, you can use ASA or AAS, and then also you can use SL, right? Okay. Yeah, so this angle, the same with this angle. And yeah, so the one that given is a PAC congruent with ABE. Right? Now you need to prove ABE. Sorry. The angle PAC congruent with the angle ABE. Right? And now you need to prove that the triangle ABE congruent with the angle PAC. Okay. And the angle given the same. So this angle and this angle are the same. And then angle PAE congruent with the ABC because they are all right triangle. Yeah. Okay. And so what else that we need to you know to prove this is a triangle congruent. I think this angle is the same, right? Because it's like reflective. I mean, not angle. This side is the same because this kind of reflective property. Okay. So side AB and side BE, they are the same, right? I think this will be the third step using reflective properties. Okay. And then using angle, side angle. So angle, side angle, we can prove that those two triangles are congruent. Okay.
Triangle congruence. So thank you so much for watching, and remember, math.
Okay. So you need to use one of these theorem in order to prove that those two triangles are equivalent. So yeah. So because this is the same, and you have in these two triangle, I mean these two angles are this not the same, congruence, right? And this side also the side is congruent. So you can use side angle side to prove those two these two triangle are congruent. Okay. Okay. I think I need to. Yeah, I need to fix the graph here. Yes, I have a problem with some other graph here. Yeah, so for the first question, I should be using side angle side, right? So the answer is one of these. This one, or this one. So you have to be careful. Okay. These two are yeah, it should be this one here, okay. One of this. One of this. Okay. This one or this one. For number two, Yeah, for number 2 is you need to complete the proof. Okay. Yeah, I need to put a new picture. Yeah, apparently the picture is not here. Okay. Yeah, if we give you the step of the proof, and then you can pick one of these. Okay, it's really easy. It just show you the step in this picture, and then you need to pick which one is the which formula that you use. Okay? SSS, SSS, or SA, ASA, or SAS. Okay? Okay, let's see here. Which is the included angle between segment PM and segment NM. PM and M. Should be this one, right? Yeah, so PM and M. So that means should be this one, right? Yeah, so this one is for you, okay? Okay, so number 4. Is this known the H and L are congruent, and then HJ, this one here, the small part here, congruent with GL, right? So that means you have angle, you have side, and also you have angle, right? Because these two angle are congruent because they are vertical angle, right? Okay. So that will be, what is that? IGH, KHGL. It should be what? Yeah. Angle, side, angle, right? So it should be one of these, this one or this one. Okay. Yeah, they are different, right? So you have to be careful, okay? Because the order of the letter is important, okay? So don't go track for this one. Okay? Number 5. Yes. If you have any question, just stop me, okay? What is the measure of the edge of angle and of the isosceles triangle if the third angle measure 32 degree and it is a congruent side measure is 15 unit. Yeah. So this is the picture of this. Yeah. So its base triangle will be, its base angle will be this one, right? This one and this one, right? Okay. So you can see here, you can assume this is X, right? Is that right? And then plus this one, so it gives you 183 degree. Okay, so from there you can find the X. Okay. Complete the proof. Yeah. So yeah, for this one, it's you the picture. Okay, I don't know what happened with that one, but it didn't show me. Maybe it didn't show us the picture. Okay. And for this one, is given RT, and yeah, RT. This one is RT. This is RT, right? RT bisect URS, URS. So, and TR, so from here to here, bisect UTS. Okay. And then, yeah, just really, this is really a easy question because one is only one step missing here. Okay. So URT equal to SRT. So URT equal to SRT. So this angle equal to this angle. So what is the reason? Do you know what is the reason? So you need to pick one of these answer. I think this one, right? The dimension of bisector, angle bisector, right? And the next one is given AD. So AD equivalent with FC, okay? And then BC equivalent with DE, okay? So use coordinate A, B, C, F to prove that angle B congruent with angle E. Okay. And yeah, so in here AP equal this AP, this one is AP this one, right? AP equal to square root of 10 times FE. Yeah. So AP equal to square root of 10 times FE. Okay. So by adding DC to put AD and FC, so make it equal, so make it AC equal with FD, right? And then, oh, sorry. And then what? And then AB congruent to yeah, so because yeah, so AC congruent with FD, right? And then how about so in this case we need to prove that this angle are the same, right? Okay. How can we conclude that this AB congruent with FE? Do you know what is the reason? So the reason will be what? AC equal to FD, and then Yeah, I think this one is something wrong. So it should be AB should be congruent with FE. Right? Okay. So yeah, so we have BC congruent with ED, and then AC congruent with FD, right? And then also AB congruent with FE. So I think this one using what? SSS? Yeah, using SSS, but using SSS, the A is SSS, right? So side. Yeah. And then to important for this one using the CPCT, right? Okay. Remember what this is? Corresponding path congruent triangle congruent, right? So if the triangle congruent, so all of the corresponding path, like the angle are congruent. So that's using the CPCTC. CPCTC. Corresponding path congruent triangle, right? Congruent. Okay. So how about this? It is equal. So this one and this one will be equal, right? Okay. So that means to find the x, you need to add this with this equal to 180 degrees, right? And then you can find what is the x. Okay, so it's 2x minus 9 plus, so because because this angle is same with this angle, right? Because isosceles triangle, right? So that means if you add this one with this one, so you get 183 degrees. Okay. So from here you can find what is the x. Okay. So what is the answer? This is 40. Maybe this one. This is 2. Okay, this 2. 180. Yeah, this is like a none of this answer. Right? Okay. You can check it. Okay. Okay, so the next one is I have to run with the time. Okay, determine what information you need to know in order to use SSS congruent postulate and to show that the triangle are congruent. So what do you think? You already know this is given that is a congruent, right? Of course, this one will be congruent because it's reflective, right? Okay, what else? Using SSS, so side, 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 right? So that means you need to determine what information you need to know in order to use SSS. I think you need to, this one is the same with this one, yeah, and this one also the same with this one. Right? So you have this is equal to, I mean this one equal to congruent with this one congruent to itself. So now you need to have the information that this one congruent with this one, right? So AD congruent with BC. Okay, so the answer should be this one. Okay. Okay. In which triangle could you use efficiently prove that triangle 1 congruent with triangle 2? So this is hypotenuse leg, right? Okay. Yeah, so this is tricky, okay? Yeah, so this is the hypotenuse, right? It is so this leg will be the same, right? So I think 3, you can use 3, and also I think can use, but this one you didn't know what is the hypotenuse, right? And this one you know the hypotenuse. If this is 90 degree and then this one is the same, so the hypotenuse will be the same, right? And also one of the leg is the same. So I think the answer is only oh, okay. Yeah, the one that is known had to be the hypotenuse, right? I think the answer to only 3, I think. So because this one is did it do you think the hypotenuse is the same? Yeah, the hypotenuse is the same, right? Because this one is equivalent and then this is 90 degree. And then this one is the leg are the same. Yeah, I think should be 1 and 3, I think, right? Okay. Let me check it. Okay. Okay, so number 11. Yeah, we're running out of time. Yeah. So ABD. Yeah, I think we can use this hypotenuse leg, right? Yeah, so you can use, I think, yes, right? So the answer is yes. And so the leg will be what? The leg will be BD, right? Because this two is the same, right? Okay. You know, to introduce the hypotenuse and leg, you need to find the hypotenuse congruent and then one of the leg is congruent, right? And one of the the angle between those, the angle between the leg and the hypotenuse has to be congruent. Okay. So the answer should be PT. Right? For 12, use a calculator. Yeah, to show this is the statement is true, right? So what then? Yeah, maybe you can put a sign here like T TV. This one is equal to this one, and then this one equal to this one. Okay, so in order to prove this triangle equivalent with this triangle, I think we need to use what? You have this and this. No, this one congruent with this one congruent with this one. So also this one is congruent with this one, right? The angle. So that means you need to use a side angle side. Right? So the answer should be one of these. Okay. Yeah. So it is also tricky also. Right? Okay. So make sure the order of the letter is correct. Okay. In order to get the correct answer. Okay. So you have a triangle CBA should be congruent with what? And MP, right? Because C is congruent with, sorry, CBA. So that means you need to find what is C congruent with P, and then P congruent with N. So the answer is P and P, P and P, yeah, P and M, right? Okay, okay, so number 13, you put A, B, C, D. This call it isosceles trapezoid, and XD equal to this. So you need to find what is the statement that is not true, right? APY will be congruent with BAX. APY congruent with BAX. You know, if you draw a line like this, so you will have to angle, right? I mean to triangle. Okay. And you can see the because it's isosceles trapezoid, so that this angle equal to this angle, and then this side equal to this side, right? And because this is equal, so this one should be equal with this one. Okay. So what do you think? Which one is this one? DX triangle DXB. Do you think we have a triangle DXB? Will be congruent with triangle DYP. Yeah, I think this one is the wrong one, right?
Yeah.
Yeah, AC should be okay. AC go like this, and then DP go like this. Yeah, I think this is the problem, right? So this is not true. Okay. You can draw the picture. Let me see here. So you have dx b like this. Right? And then you have dy dy p go like this. Okay. So what do you think? I don't think it's equivalent. Right? Yeah, maybe you can use the GeoGebra, okay? So to make sure. Okay, so yeah, again, so you need to complete the proof also, okay? And it's given BC equivalent to DA, and then this angle equivalent with this angle, and then CF, this one, equivalent with this one, okay? So what did you get? And then you know you need to prove is CEF congruent with AEF. Okay. I think you have this one is congruent, right? And what else? Okay, so third one here. Okay, sorry. So so angle BCE congruent with the DEA because it's vertical angle. Right? Okay. And so now you can prove that PEC congruent with DEA by what? Side angle side, right? Or angle side. I think angle side, right? Because this angle the same with equivalent with this congruent with this one, and then this angle congruent with this angle, and then this side congruent with this side. So yeah, using angle side. Okay. And then using CPT, you can, because these two triangles are the same, so this side and this side, sorry, congruent. These two triangles are congruent, so this side and this part also congruent. Okay. Congruent. Okay. So this one is clear because using reflective property. Okay. So this one equal to this one, and then this one equal to this one yourself. So, and what else? I think there's one. Yeah, so this one is no from here, right? Okay. So you need, so you can see the CE equal to EA, and then this one congruent, right? This one itself is congruent plus reflective property, and this is given for the CF congruent to AF. So I think so. This will be using. So for the A, remember what is the A? Using what? angle, side, right? And then the B using SSS, right? So angle, size for the A, and the B is side, right? Okay. Okay, I think this one is repeated again. Okay, but this one is, yeah, you have make sure. I think you can do this one, right? Okay, just skip it. I'll apply for you. Okay, so I'll leave it for you. Okay. So you need, because this is isosceles triangle, so this I mean this angle equal to this angle. So that means if you add this with this, give you 180 degree, right? And you can find what is the x. Okay. Yeah, so this is by definition. Okay, so you need to read again the definition. Okay, and you can answer this question. Okay. And number 18. Yeah, so you know this one equal to this one. This is 180 degree. Okay. So you can assume what is x. This is x. This is x. Right? So you have to x plus this give you 180 degree. So you can find what is the x, right? Okay. Or the angle CD. I mean the angle D. Okay. And yeah, you can figure out by yourself. Okay. Because we run out of time now. Okay, sorry. Yeah, this is IK, GS, congruent, and then this is congruent. Okay. So automatically this one is congruent. Okay, so you have side, side, side. Okay, so the answer will be HJK, HJK, and then yes, you have to be careful here. Okay, HJK, and then KIH. Right. So HJK and KIH. So I think the answer should be this one. Okay. So this is bonus for you. Okay. Okay. So number 20 is you need to complete the true also. Okay. Yeah, you can figure out by yourself. Okay. Because we run out of time now. Okay. Okay. So this is for today. Okay. So hopefully you can complete the assignment by the weekend. Okay. So I will post it this exam as soon as possible. Okay.